Hello and welcome to the Calculus Equations program from mcstudium.com. So just so you know, this will work on your TI-84 plus CE or TI-84 plus CE Python calculator. It doesn't have to be Python, but it could be. So let's show you where to go to get this. So we're going to press PRGM, which is this key in the upper middle portion of the keypad. And then if you do have a Python calculator, it's going to give you this choice. Otherwise, it's going to be TI Basic if you have just a regular TI-84 plus CE. So we're going to select the TI Basic. There we go. We press Enter. And then if you have more than one program, you have to select which one you want. So you can actually just press 1 for Calc EQ6. This is Calculus Equation version 6. And then this is the funky part. This is where people get stuck. You have to press Enter twice. It's 80s technology, so please be patient. And there are an assortment of videos to walk you through all the programs available from mcstudium.com. So without further ado, let's get through this. This is the main menu. It has basic derivatives, trig derivatives, inverse trig derivatives, hyperbolic derivatives, miscellaneous derivatives. Basically, this is enough to carry you through Calc 1 and Calc 2, or for if you're in high school, AP Calc AB or AP Calc BC. We also have a more menu. Just walk through that real quick. Limits, reminders, concept help is a big one. We're constantly expanding that. Integrals, specific BC topics, Calc BC, that's Calc 2. FTC, fundamental theorem of calculus, graph analysis. I wish I had a back key, but whatever. When you run through the program, you just press Enter to rerun it. So you're going to go over basic derivatives. So here you go. It's just displays of the formulas for you guys. So the basic derivatives, the d over d of x of c, if a constant is 0, c is a constant. I don't need to walk you through all this, but the cool thing is we did fix the quotient rule here. It's ba prime minus ab prime, all divided by b squared. And if you have the absolute value of u, it's u divided by absolute value of u, all that times u prime. So let's go over some trig derivatives. As you can see, the basic ones, the ones that mess people up, it's not really sine and cosine so much, but the tan, cosecant, secant, and cotan. And then inverse trig derivatives, arcsine. Now this is a little old notation. This was kind of getting old when I was your age, so this is really, really old for you guys. You guys might have it as like sine to the -1, like inverse sine. Arc sine and inverse sine, same exact thing. So it's an inverse trig. So inverse sine, inverse cosine, inverse tan, inverse cosecant, inverse secant, inverse cotangent. And there you have it there. These, oh my gosh, this reminds me of Space Invaders back in the day. It's a program that's got to be 40 years old. But in any case, that's multiplication symbol. So we go on. Hyperbolic derivatives. Hyperbolic derivatives. There we go. Sorry about that. Sinh, cosh, tanch, hyperbolic cotan, hyperbolic secant, hyperbolic cosecant. So these are examples right here. And another student asked for U substitution examples for hyperbolic derivatives. We're going to do that, but that'll be the next one. Here it's early October. I'm thinking it'll be mid-October before I get to that. Again, free updates once you buy the program, so you're totally fine. Miscellaneous derivatives. I saw these on students' finals on Calc AB, and they're like, hey, this isn't in my textbook. This is back in the day. This is like 90s, early 2000s, and 2000 teens. Nowadays they have it. But the derivative of ln of u is u prime over u. Derivative of e to the u is e to the u times u prime. And then derivative of a to the u is ln of a times a to u times u prime. So look, this, just so if you're familiar or not familiar with the notation, log base a of x equals 1 over ln of a times x. That whole thing is in the denominator here, this whole thing. And if it's the derivative of log base a of u, it's u prime all divided by the product of ln of a times u, just so you know. And this is, look, I'm just showing you everything, so it's going to be a little bit of a boring video. Not unlike the rest of my videos. We got some limits information. Now, some people call it Hospital's rule or L'Hôpital's rule. It's French, so I'm pretty sure there's probably a silent S there, but Kids would argue with me. It's called the Hopital or called the hospital rule. Let's just give it a break here. So this is the limit of f of x over g of x if it's 0 over 0 or infinity over infinity. So just so you know, I put inf means infinity. Limit of f, it's limit of f prime of x over g prime of x. Common limits, by the way, limit is x approaches 0, sine of x over x equals 1. Look, this thing is so common. It's on, man, if you're in Calc AB, at least one quiz or one test or one exam or one final. Almost guaranteed. Then we have limit as x approaches 0. 1 minus cosine x divided by x squared is 1/2. And then all these other ones, limit as x approaches infinity, 1 plus 1 over x raised to the x equals e. That's how they get that number, the 2.718 thing. Yada, yada, yada. I think you can read the notation after that. We're going to go to reminders here in the more menu. So, you know, most people are like, oh, sine of x, derivative of sine of x is cosine of x. But watch, if you have the derivative of sine of u, it's cosine u times u prime. So an example of this, if you have sine of 3x, and this is what messes people up. They should be learning the u's rather than the x's. So if derivative of sine of 3x, it's cosine of 3x, right? Just as you thought, times 3, derivative of what's inside here, derivative of the 3x part. So just remember that. That's sort of put that there for the reminders. Concept help. Oh my goodness. So we got a lot here. And look, a lot of this is driven by students. Students will contact me at the mcstutoring.com site and say, hey, can you add chain rule, product rule, quotient rule? And I'm like, hey, yeah, I'm happy to oblige. Just know that there's a queue because at any one time, there's between 3 and 8 students asking for expansions of programs. It takes them anywhere between 3 days to 3 weeks to implement the changes, depending on how complex they are. Okay, so here we are in chain rule. So if we have y equals f of g of x, then dy over dx is f prime of g of x times g prime of x. Here's an example. If we got y equals, and by the way, this is the raised to symbol, this caret symbol here, it's right here above the division symbol here, so raised to the power. So if we have sine of x squared, then derivative is cosine of x squared times 2x, derivative of the inside there. So derivative of x squared is 2x. So when to use when you have a composition of functions, a function inside another function. There we go. Let's go to product rule. So here's product rule example. If we have x times sine of x, the derivative would be, right, the f prime x times g of x plus f of x times g prime of x. So derivative of x is 1, and then we keep sine of x, and then plus the first function as it is, so x stays the same, and the derivative of the second function. So the derivative of sine x is cosine of x. When to use when you have two functions multiplied together. So it's pretty straightforward. And if you do see room for improvement, please contact me. I am open to it. Just be patient. Quotient rule, we've got an example. If y equals 10x, really that's like sine x over cosine of x. And there we go. It's going to be, what is it? It's going to be, sorry, just buffering here. G of x times f prime of x minus f of x times g prime of x. So here's the example with sine divided by cosine. And then it works it out. We got secant x squared. Okay. Or secant squared x, actually. Sorry. Or is it? I don't know. You'll figure it out. When you have a fraction with functions in numerator and denominator, that's when you use it. And then we can go to Hopital's rule. And then there we go. You may need to apply it many times. That's more like a Calc 2 thing. And inf means infinity. Then we're going to go to 5 for related rates. Now look, this is the steps to related rates. Assign variables to quantities. So for instance, like a cone, you have height and radius typically. Write equation relating to variables. Differentiate with respect to time. Substitute known values. Solve for the unknown rate. So I think we have cone with a volume v equals pi r squared h over 3. If height h, not height, but height h equals 3r, and dr, basically delta r over delta t equals 2, find dv over dt when r equals 5. So we got the basic equation, and then we plug it in. It looks like, oh, it's works out to be v equals pi r cubed. So then dv dt is going to be 3 pi r squared times dr dt. And we said, oh, dr dt is 2. We're going to substitute that in, and there we go. I didn't solve it. I just, got you through enough so you can figure it out. Let's go back. So that was the concept help. Now we're going to go to integrals. Pretty big menu here. We got basic integrals. There you go. Integral of c times f of x dx is, you can pull the c, the constant, out, times the integral of f of x dx, assuming c is a constant, okay? Integral of 1 over x dx is ln absolute value of x plus c. Now look, I put a lot of this stuff because I want to go back in time and give myself this when I was in calculus class. I forgot to put the plus c a lot, so shame on me. And I just want you to know, put the plus c, guys, when you have a indefinite integral. Integral of du equals u plus c. Integral of x to the n d of x is x to the n plus 1 divided by n plus 1, all that plus c, so long as n does not equal -1, because otherwise you're dividing by 0. So we also, the integral of f prime of x over f of x dx is ln absolute value of f of x plus c, yada, yada, yada. Oh, integration by parts here, by the way, at the end, I think. We got trig integrals. So look at that. Oh my gosh, I would hate to have to memorize this again. But you get the drill. You get it. You figure it out. We're going to go inverse trig integrals. So if you have the integral of du divided by the square root or radical a squared minus u squared, it's arc sine u of a plus c. So remember arc sine, same thing as inverse sine. Sometimes it's called arc sine. And then we go on. Same thing here. Oh my gosh, I will fix this. I will fix this. Oh my gosh. I got to write a note to myself. I got to fix this. Inverse integral. Oh my gosh, inverse trig integral. Okay, I'll fix it. I'll fix it within the week. So by mid-October, this will be fixed. Okay, I can't believe it went off the page. Okay, now hyperbolic integrals. Let's see. Hopefully everything fits on the page. Yes, it does. Okay, cool. It's pretty long, but there we go. Hyperbolic integrals. Then we go exponential integrals. I put this because this is just a pain in the butt sometimes. Integral of e to the x d of x is just e to the x plus c. Integral of ln of x d of x is x ln of x minus x plus c. Key one here. A lot of people forget this one. Integral of a to the u du is a to the u divided by ln of a plus c. And the integral of eu du is e to the u plus c. Last thing, integral of 1 over x dx is ln absolute value of x plus c. Cool. Let's go on to integration techniques. So use substitution. Look for f of g of x times g prime of x pattern. So let u equals g of x, du equals g prime x dx. Integration by parts is integral of u dv is uv minus integral v du. Key thing here, so just remember that. And then we have liate. So we do, in that order, logs, inverse trig, algebraic, trig, exponential. Choose u in order. So trig substitution. By the way, integral of, square root of a to the x, a squared minus x squared. I'm getting bleary-eyed here. X equals a times sine of theta. And if we have square root of a squared plus x squared, we're going to set x equal to a times tan theta. Sorry about that. I feel I'm just going to be making a lot of mistakes in this video. So just go with what's written here. Integration techniques continued. Square root of x squared minus a squared, you want to let x equal a times secant theta. So partial fractions decompose rational functions into simpler fractions. That's a super summary, meaning super concise. Probably more would be better there. Let me know in the comments if you'd like me to add more, and I will. And then we've got definite integrals. Definite integral, integral from a to b f of x d of x represents area under curve f of x from a to b when f of x is greater than or equal to 0. The net area is area above x-axis minus area below x-axis. So just keep that. That's a good thing to keep in mind. And it's accumulation of change when you do integrals. Properties, we got integral a to b f of x dx is negative the integral of b to a f of x dx, used all the time on finals. So you just got to be able to shuck and jive with that. Integral of a to b f of x dx is integral of a to c f of x dx plus integral c to b f of x dx, assuming, by the way, c is somewhere between a to b. Probably should add that. Left and right Riemann sums. You've got trapezoidal rule. There you go. That's just shorthand notation. And then Simpson's rule. N must be even for, I think, number of subintervals. So we go on. Oh my gosh. I think that was it. We're going to go back. Geez, now we're just still on BC topics here. We got series and sequences, usually called sequences and series. I don't know why I wrote that. Taylor series, polar curves, vectors, parametric equations, Euler method. So, sorry, Euler. Oh my gosh, Euler. Euler. Okay, Euler. I know how to speak German. I should know that. Okay, series and sequences test. Nth term test. If limit as n approaches infinity, a of n is not equal to 0, then the series diverges. Geometric series, sigma r raised to the n converges when the absolute value of r is less than 1. 2, it converges to a divided by 1 minus r. P series test, you got sigma notation, the sum of 1 over n raised to the p, converges when p is greater than 1, diverges when p is less than or equal to 1. Ratio test, limit absolute value of a to the n plus 1 over a to the n equals L. If L is less than 1, it converges. L greater than 1 diverges. If L equals 1, it's inconclusive. My gosh. Continued. Root test. Limit absolute value of a n raised to the 1 over n equals L. Again, we got converges, diverges, inconclusive. Alternating series test. You probably already know this. Comparison test, etc., etc. Oh my gosh. And then more continued. I don't know how you guys memorize this. I don't know how I memorize this. Sorry. Oh my gosh. Taylor series. There we go. Taylor Maclaurin series. Taylor series at x equals a. And then Maclaurin series, I think, at x equals 0. We got f of x equals the sum f raised to the n a divided by n factorial times x minus a raised to the, oh my gosh. Look, I'll assume if you're in BC, Calc BC, you understand the gist of this. This is just going to give you a reminder here. Polar curves, I used to understand. R equals f of theta defines a polar curve. So the area is going to be the integral of 1/2 r raised to the 2 d theta. Arc length, there we go. Converting to rectangular, x equals, oh, this is good. I used to forget this sometimes. X equals r cosine theta, y equals r sine theta. Common curves, if you have a circle, it's r equals a, or if you have r equals a, it's a circle. Cardioid would be r equals a times the quantity 1 plus cosine theta. And then rows, r equals, that kid's outside, so don't think anybody's being hurt while I'm filming this. He lives across the street and down a few houses. He's just having a tantrum, I think. He's a good kid. R equals a times cosine n theta, or a equals, a times sine n theta. We all have our moments. He's just having his. Now we go to vectors. Vectors, you got velocity vector, speed, acceleration, unit, tangent, arc length, curvature, normal vector. Oh my goodness. And binormal vector. Gosh, I've forgotten a lot. Parametric equations. I think you already know this, but this is just a reminder. And then Euler method. For differential equations, dy of dx equals f of x comma y with initial value y of x sub 0 equals y sub 0. Steps, choose step size h, set x of n equals x sub 0 plus n. I think that's times h. I'm not exactly sure. Flame me in the comments if I'm wrong. Compute, and then error, and then runge, cut. Oh my gosh. And then we're going to go back. Is that everything? That was just BC topics, right? Okay. Fundamental theorem of calculus. There we go. Part 1. That's capital F of x, equals integral of 8x f of t dt. Then f prime of x equals f of x. Fundamental theorem of calculus part 2, integral of a to b f of x dx equals big F of b minus big F of a, where f prime of x, big F prime of x, is basically we're saying the derivative of the integral is the function itself. Examples, find t over dx, integral 0 to x squared sine t dt by fundamental theorem of calculus, 2x times sine x squared, chain rule with fundamental theorem of calculus. Continued, oh my gosh, part 2. There's another example. I don't want to bore you. I just want to show you what it does have. And then graph analysis, by the way. First derivative test, you guys probably already know this. If f prime of x is greater than 0, f is increasing, the function is increasing. If f prime of x, like the derivative, is less than 0, it's decreasing. If f prime of x equals 0, it's a critical point. And then continued, second derivative test at critical point x equals c. F double prime of c greater than 0 means it's a local min. F double prime of c is less than 0 is a local max. F double prime of c equals 0, it's inconclusive. Use first derivative test. If f double prime of x is greater than 0, concave up. F double prime of x is less than 0, concave down. Points of inflection, f double prime of x equals 0 undefined. And concavity changes, curve sketching steps, find domain, find y-intercept where x equals 0, and x-intercept y equals 0, find asymptotes, find critical points using f prime of x equals 0. And then determine increasing and decreasing using first derivative test. Then find inflection points using f double prime of x equals 0. Determine concavity, and then sketch the curve. Oh my goodness. There's more? Oh gosh. Okay. For differential equation, dy over dx equals f of xy. Draw short line segments. Okay, this is like hash marks. There's actually a program I have for this for slope fields. I'll actually put it up on the mcstutoring.com site. Just remind me in the comments, like say, hey, and I'll do the slope field one. I will put it as a free program. Helps visualize solution curves. Solution curves are always tangent to slope field. Follow flow to estimate solutions. I think you probably know that if you've seen it. It's just a good reminder. I'm going to exit. Man, for real, thanks for using calculus equations. mcstutoring.com. You guys already know the site. If you like the video, like it. If you want to subscribe, subscribe. And feel free to contact me. I've had easily a dozen, probably more like 24 students already contact me for ways to improve, add, or change things to the programs. And I did, I'll honestly admit I made a mistake on the calculus equation program because the second version cut off a lot from the first. So this sixth version added a lot. It combined the best of the versions 1 and 2 and added a lot more. But look, version 7 will probably be out mid to late October, hopefully by Halloween, to help you guys out. But look, take care. Good luck in your calculus. I'll catch you next time.